Hello and welcome to the ultimate study guide for your first quarter exam. Mr. May's examination is right around the corner and I'm here to help you ace it. Today, I'll delve into the core concepts we've covered in class, breaking them down into easy to understand segments, complete with visuals and mnemonic devices that will make studying a breeze. We're covering it all from distance and displacement to vector addition, with engaging examples and creative ways to memorize all those pesky equations. We'll start by defining each topic in our own words, breaking down the key terms. Then we'll use visuals, fun examples, and mnemonic devices to help cement your studying. Distance is the total path covered, while displacement is the change in position from start to finish. It's like taking a scenic detour rather than going in a straight line. Now, let's use a fun example. Imagine you're going to the grocery store. Say they're 2 miles away from each other, but in total you drive 6 miles. That's 6 miles right there. Because you decided to take a nice scenic detour through some nice trees and nice foliage, right? So instead of going in a straight line, you went the detour and you drove your car in 6 miles of distance. So your distance is 6 miles. That's how far you've went. But your displacement, since you're now at the grocery store and you started at your house, your displacement would only be 2 miles, because you're just 2 miles away from where you started. Displacement is just relative to your starting point. Next topic. Now let's zoom into speed and velocity. Speed is all about how fast you're going, like driving 60 miles per hour. But velocity is not just speed, it has direction. It's like 60 miles per hour due north. Here's a handy way to remember it. So speed is all about how fast you're going. So 60 miles per hour. Speed right here. But velocity is similar to speed, but velocity is not just speed. Velocity is speed with a direction. It's like 60 miles per hour to the north. So remember, speed, no direction. Velocity, direction. And with that, we arrive at acceleration. Acceleration is all about change in velocity, speeding up, slowing down, or changing direction. Alright, so imagine a race car on a track. When it accelerates, it goes from standstill to full speed. It's like hitting the gas pedal. Your acceleration is moving forward here. But when you hit the brake and slow down, then you have a negative acceleration. Remember the formula. Acceleration equals change in velocity over time. It's like the rate of change in your speed. Alright, you got the basics down. What's next? Next up, we've got position, time, and velocity time graphs, essential tools to visualize motion. Position time graphs show an object's motion at different times, while velocity time graphs illustrate how an object's velocity changes over time. This is a position time, and this is a velocity time graph. Remember, on a position time graph, a straight line means constant speed, while a curve indicates changing speed. Now for velocity time graphs are like motion stories. The slope of the line tells you about the object's acceleration. Now let's experience the thrill of free fall, like this guy. Free fall is when an object falls under gravity's influence with no other forces involved. Think skydiving, or dropping an object. Whether it's you plummeting from a plane or an apple falling from a tree, it's all about the force of gravity pulling you down. Gravity pulls things down at a rate of 9.8 meters per second. Think about throwing up a ball. At first, it goes up fast, but then gravity will pull it down by 9.8 meters per second until it hits the floor again. Like this. After the ball, you throw it up here, yay! And then, it stops going up eventually because it doesn't just go up forever. And then it comes down, and then that's it. Yeah, that's because gravity is always pulling it down at 9.8 meters per second.
Remember, 9.8 meters per second. Stay with me now.
Next on our journey through physics, we have vectors and scalars. Let's distinguish between the two. Scalars are quantities with just magnitude, like speed or distance. They have no direction. When you think scalar, think of this. The arrow, direction, with a big cross over it. Scalar means no direction. On the other hand, vectors are all about both magnitude and direction. they have that arrow to guide you, like velocity of force. So, think of an arrow without the cross sign over it. A quick way to remember, if that doesn't work, remember this. Scalars are simple numbers. Vectors are numbers with direction.
You know, we're almost there. We've got one more thing to cover. Vector addition.
This is where vectors come together in different ways. The head-to-tail method is like connecting the heads of one vector to the tail of another. It's how we add vectors that don't act at the same time. Say Mr. May's examination gives you a question that looks like this. One arrow going that way, one arrow going that way. What do you do with this? Well, what I do is I take this first arrow and I draw it. Head-to-tail method. You take the tail of this one and connect it to the head of this one, head to tail. So boom, you go like that. That's your answer, right there. Head to tail method. Now say he wants you to find the resultant of this. No problem. Just take the original point where you started, which was right here, the first one you drew, the original tail right there. And you just draw an arrow, just kind of sprouting from that tail. You connect it there. And this right here is your resultant. Boom. Oh, drats. Mr. May threw in a question about concurrent vectors. Not to worry, this is how concurrent vectors are done. So, you start here. This is what you have initially. You need to find a resultant. So what you do is you take this one, you copy, and you paste it over here at the head of this one, right? So you have, now, so you copy and paste. Now you have that one, right? So you do the same thing for this one. You take it, you copy it, paste it right up here. Boom. All right, now what? So you started here. Your resultant's gonna go right from here, right through there, and that's your resultant, and that's concurrent vectors. That's it, you've mastered vector addition, both head to tail and concurrent. So, there you have it, a comprehensive study guide covering all the core topics for Mr. May's exam. From distance and displacement to vector addition, you're ready to tackle any physics challenge. Best of luck and happy studying.
Congratulations. Now, you're ready for Mr. May's Core 1 examination.